Hello everybody, my name is Ranger Raider Lane.
And I'm Ranger Joel Kane.
And on behalf of the National Park Service, we want to welcome you to the 2020 Virtual Geology Festival.
Absolutely, thanks for joining us. We are two of the conveners of the Virtual Geology Festival here at Grand Canyon. I'm going to serve as your host and friendly ranger guide for this coming week. Ranger Raider has been a lot of help behind the scenes putting this whole thing together, so we decided to kick things off here with just welcoming you to this virtual GeoFest, which you might be wondering what that is. What is a virtual geology festival? Well, over the course of this coming week, every single day, I'm going to be sitting down for presentations and conversations with some amazing geoscientists and educators, people who have dedicated years, sometimes decades of their lives and careers to studying and researching and exploring Grand Canyon's geology, all to further our understanding, increase our knowledge about this incredible place, one of the most iconic and incredible geologic features on the planet.
Yeah, and you know, this place it's not only a national park, it's not only a World Heritage Site, this is one of the 7 natural wonders of the world. And it goes much farther beyond that. I mean, this is, in a lot of ways, a temple of deep time, a place where people can go to think about these large questions that we all have, our place in the universe, our place on the planet, and how this planet came to be. And that's one of the things we celebrate through this geology festival. It's just that pursuit of knowledge. We can enjoy the aesthetics of the canyon for years to come, but it sometimes is an amazing thing to really understand the processes by which the canyon was formed, and that sort of augments our experience, or we like to invite you to think that that might augment your experience. And that's why the geology of the canyon is one of the primary interpretive themes, one of the main resources that makes Grand Canyon National Park so incredible.
Absolutely, it's part of our mission to protect and preserve the geology of Grand Canyon National Park, along with all the other incredible things about it. It's also part of our mission to try and bring that knowledge to all of you out there. And this is going to give you all a chance to actually interact with and ask questions of some of the geoscientists and researchers and educators who are responsible for a lot of what we know about the geology of Grand Canyon. Now, these are the people who are out there floating down the Colorado River and hiking out to some of the most inaccessible areas of the canyon. People are hauling heavy rock samples up out of the canyon to take to the laboratory to study and analyze. You're going to have the chance to actually interact with those folks who can sometimes seem a little enigmatic and mysterious, tucked away off in the lab somewhere. You're going to be able to see who these folks are and actually ask them questions over the course of the week.
You know, and we've been talking about all these amazing scientists who you're going to be able to interact with. There's 150 years or more of this pursuit of knowledge about the canyon's geomorphology, its geochemistry, its geophysics, and we've come to understand a great deal about this canyon. We're still asking a bunch of questions, as you're going to see throughout this week, but it's incredible to be able to understand and look at this vast amount of knowledge and understanding we've gained over the past 150 years or so of our history here. But it's also important to realize that there is a deep understanding and knowledge of this place that goes back for thousands and thousands of years. And so we want to take the moment here just to acknowledge the 11 traditionally associated tribes of Grand Canyon who hold on to, protect, and preserve that deep knowledge that has persisted for thousands of years and that continues on to this day. And that's something that we like to celebrate here at Grand Canyon National Park.
Yep, definitely. I mean, some of these geoscientists and researchers are going to be presenting some of the most up-to-date and cutting-edge research, some of the latest and greatest discoveries about Grand Canyon geology. And towards the end of the week, we're going to be kind of summarizing the current state of what we know, what we think we know about Grand Canyon's geology right up to 2020, kind of summarizing that last 150 years of what we now think of as geologists working here at Grand Canyon. But it's definitely important to remember that there's other types of knowledge going much farther back than those 150 years. But whether you are going to stick it out for every single talk over the course of this whole week, or maybe just join in for one or two, that kind of interest you. Whether you ask, 1,000 questions of these folks over the course of the week, or, answer none or ask none at all. We're happy to have you. We're happy to be able to put this thing on, and we hope you all enjoy it. So thanks very much for being with us.
Hope you enjoy.
Hello again. As I said in our welcoming message a moment ago, my name is Ranger Joel Kane, and I'm pleased to welcome you here to Grand Canyon National Park for Earth Science Week 2020, and of course the Grand Canyon Geology Festival, or GeoFest 2020, which is going to be running this entire week. And we've got a lot of amazing talks lined up with geoscientists and educators from all over the country, people who specialize in Grand Canyon geology. Now, of course, we talk a lot about geology here at Grand Canyon National Park. We give regular talks on the subject. So I thought we would start things off this week with one of those talks from yours truly, because you're going to be seeing a lot of me over the course of the coming week. I'm going to be sitting down with all these folks and talking with them, having conversations with them, and I'm also going to be taking you to different places within the park to show you some of the things that we're talking about. Places, for example, like right here. I'm out here near Pima Point on the south rim of Grand Canyon. It's one of my favorite viewpoints. We've got some amazing views of the Colorado River out here. Right down there, there's a gigantic rapid on the Colorado called Granite Rapid. Another nice river view off there to the west. Since I am going to be your host here for this week, I also thought it would be good to start things off with answering some questions like, well, who am I? And why am I hosting GeoFest 2020? Well, I'm also a geologist. In addition to being a park ranger, I'm a geologist myself, and I've harbored a lifelong fascination with geology. I've loved geology and paleontology ever since I can remember, since I was a little kid. I grew up going down to the Smithsonian Natural History Museum in Washington, D.C. Used to walk around and gawk at all the dinosaur skeletons. Wanted to be a paleontologist when I grew up. And when it came time to go off and decide on something to study in college, well, I decided on geology, which of course paleontology is a part. So I got my undergraduate degree in geology at UCLA in Los Angeles, in California, of course. While I was studying geology there in California, I started doing a lot of traveling, visiting a lot of national parks in California, Arizona, Utah, Oregon, and I started to come to the realization that national parks preserve some of the most incredible geology on the planet. And I started thinking, well, if I were to go to work for the National Park Service, I would get to be in some of these amazing places that have some of the most amazing geology in the entire world. So after I finished my undergraduate degree, I decided to go off and work for the National Park Service. Something that also influenced that decision was a trip I went on my senior year as an undergraduate. We took a trip to Zion National Park up in Utah, and then to the North Rim of Grand Canyon. That was the first time I had ever been to the North Rim. Been to the South Rim twice before, but only up on the rim. Never had the chance to hike down into the canyon before. So that trip was also the first time I ever actually hiked down into Grand Canyon from the North Rim on the North Kaibab Trail. It was just a day hike. Of course, I did not hike to the bottom. We never recommend hiking all the way to the bottom and back in a single day, especially from the North Rim, because that's a really long hike. But I did hike down farther than I should have. For those of you who are familiar with the trail, I hiked down to a spot called Ribbon Falls, which is a really incredible place deep within Grand Canyon, and that was a life-changing experience. It helped me decide what I wanted to study in graduate school, and it helped me decide to come work for the National Park Service, although I didn't imagine then that I would end up working here at Grand Canyon National Park. Now, the first national park I actually worked at is a place called Fossil Butte National Monument up in Wyoming. Most people have never heard of it, let alone been there. But if you like fossils, if you like paleontology, it's an absolutely incredible place. I highly recommend visiting there. And then I actually worked a winter season at Zion National Park up in Utah.
And then after that, a summer at Oregon Caves National Monument in southern Oregon, which, if you like caves, is also a really cool little place to visit. And I've been here at Grand Canyon for the past 6 years. And during that time, I've also been working on my master's degree in geology just down the road at Northern Arizona University in Flagstaff. And some of our speakers this week are current or former faculty or alumni also of Northern Arizona University down there in Flagstaff. So I am absolutely honored to be here at Grand Canyon. I'm honored to be hosting this event for you all. I hope you enjoy it. Like I said, we do have a lot of amazing speakers lined up, people I'm really excited to sit down and talk with, so I hope you are as well. I'll tell you one thing, over the 6 years that I've been working here at Grand Canyon, one thing I've come to realize is the more I learn about this place, the more I understand about Grand Canyon, the more incredible it becomes, and the more questions I have. Geology is kind of like that, in Grand Canyon especially. This is the sort of place where, you know, you answer one question and two more pop up in its place, kind of like the Hydra of Greek myth. So my understanding of this place is continuing to develop and deepen over time. And I've come to realize that it's a really, really incredible place, not just the geology, but the ecosystems out there, the biodiversity, the human and cultural history here at Grand Canyon. This is a really, really incredible place. In addition to being one of the most spectacular geologic wonders on the entire planet. And I wanted to start off things as well with a few fundamental questions. For those of you who are out there who are not geologists, that first question I really kind of wanted to answer is, what is geology? What is geology all about? And what do geologists study? And when I ask that question, a lot of folks, the first thing that comes to their mind, the first thing they say is rocks, right? Geology is all about rocks. Geologists love to study rocks. You know, we go out there and we find some cool rocks and we start staring at them really, really closely. And then we pull out hammers sometimes, although not in the national park, unless you have a permit, and start chipping away at those rocks and picking up pieces of them and looking at them even more closely. And then sometimes we take them back to the lab and look at them even more closely. And a lot of people think we're kind of nuts for, you know, it's like, well, they're rocks, you know, how interesting can they be? But they're actually pretty fascinating, and we learn a lot by studying rocks. But geology is actually about a lot more than just rocks. It's a big science. In addition to rocks, geologists study things like mountains and rivers and deserts. They study things like earthquakes and volcanoes. So geology is actually a really, really big science. I mean, we study things like the atmosphere, the oceans, a lot more than just rocks. But rocks are, they're kind of a big part of geology, a big part of what we study, because they're one of the primary clues about Earth's history. One of the biggest things that we use to figure out, you know, how our planet got to be the way it is today, and what happened over the course of our planet's history. Now, of course, a problem here at Grand Canyon is, I don't know if you've noticed, we're actually missing a lot of rock out there. Quite a bit, as a matter of fact. I mean, there is a lot of rock in Grand Canyon, a lot of really beautifully exposed rock, but there's also a lot of missing rock, hence the fact that there's a gigantic canyon there. So, in terms of trying to understand Grand Canyon, we have to deal with the fact that a lot of those clues and pieces of evidence that we would use to understand it are gone. They're actually missing here at Grand Canyon, which presents a problem. And we're going to learn a lot more about problems like that over the course of this coming week. But I also want to talk a little bit about, well, how do geologists think? How do you have to train your mind, you know, in order to be a geologist and study things like this? And one really tough thing about thinking like a geologist is the fact that we have to think about the surface of our planet in ways that, and our planet as a whole, in ways that most folks don't. You know, generally speaking, walking around up here on the surface of the Earth, it's it's more or less a two-dimensional surface. Geologists actually have to think in 3 dimensions. So they have to look at a mountain up ahead and wonder, you know, well, what's going on inside that mountain? What is going on deep beneath our feet? We look at these cliffs of Grand Canyon, these exposed faces of rock, and we wonder, well, how far does that layer of rock extend? If I follow a layer of rock for a mile or 10 miles or 100 miles, will it still be there? Will it still look the same? Will it maybe have changed to a different kind of rock? Will it suddenly bend and fold and plunge down beneath the surface of the earth and you can't even see it anymore? So these are some of the questions that we kind of have to think about spatially when we're thinking about geology and when we're thinking about our planet. But it gets even more complicated than that, because geologists also have to think in 4 dimensions. The 4th dimension, of course, being time. And geologic time is a concept that geologists spend their lives trying to wrap their heads around. It's very different from human time. We live our lives on the scale of minutes and hours and days, weeks, months, years. Decades are a pretty long period of time for us. Centuries, that's, history. It's what we learn about in history class. Thousands of years, going back to like when the pyramids were being built in Egypt, for example, that's ancient history to us. Even 1 million years in human terms is an incredible amount of time. In geology, we're talking about tens to hundreds of millions of years, billions of years. Geologists spend a lot of time trying to wrap their heads around those concepts, and time is an extremely important concept in geology that we're going to be talking quite a bit about over the course of the week. And I also wanted to talk about some basics of geology. I don't want to get too much into it because I don't want to give too much away. A lot of our speakers are going to be talking in great depth, pun intended, about Grand Canyon's geology. So I don't want to give too much away about it, but I do want to talk at least a little bit and give some kind of basics about geology, some things that will maybe help folks out there understand all of what we're going to be talking about over the course of the coming week. And let's start with rocks. I mean, since rocks are so important, so fundamental in geology, let's talk a little bit about rocks. Many of you might know there are 3 different types, 3 big groups of rocks. And those, of course, are igneous, sedimentary, and metamorphic. And we actually have all 3 types of rock here at Grand Canyon. We have a lot more of one type than we do of the other 2. The type, of course, that we have the most of is sedimentary rock. And that is for most of what you see out here in Grand Canyon. The igneous and metamorphic rocks that we have here at Grand Canyon are way, way, way down there at the bottom. So most folks don't actually get all the way down there to the very bottom to see those rocks, although we are going to be talking about them, and I might just take you down there at some point to show them to you. So stay tuned for that. But those rocks down there at the very bottom of the canyon are known as the Vishnu basement rocks, and they're a mixture of actually igneous and metamorphic rocks. Now, igneous means formed from fire, so igneous rocks are formed from magma or lava. Of course, basically the same thing, it's just a matter of where it is. Lava is up here on the surface of the planet, magma is down inside the planet. And as magma comes up to the surface, as lava, it starts cooling down, it hardens, and forms new rocks. And those are igneous rocks. Metamorphic rocks, kind of tricky, kind of complicated. They're formed from other rocks that have been subjected to intense heat and pressure, typically deep down inside the earth. You put rocks under enough heat and pressure, they'll actually start to change. Minerals within the rocks will start changing into other minerals. They'll start to actually align themselves. So metamorphic rocks often look pretty cool. And that's what those rocks are down at the very bottom of the canyon. They're also the oldest rocks that we have here at Grand Canyon, because there's a very, very fundamental law in geology called the law of superposition. Oldest rocks down here at the bottom, younger rocks gradually form on top, getting younger and younger and younger the farther you go up. So the oldest rocks down there at the very bottom of the canyon are almost 2 billion years old, about 1.8 billion to be exact. And that's almost half the age of the Earth. And then, of course, the other rocks, as you go further and further up, get progressively younger and younger and younger. Now, all those colorful layers that you see stacked out there on top of those Vishnu basement rocks, those are all sedimentary layers of rock. And sedimentary rocks, believe it or not, are made of sediments. It's in the name. Now, sediments are basically little bits and pieces of broken up rock that have been transported, sometimes great distances, by rivers and streams, like the Colorado, for example, and then redeposited to form new kinds of rock. You pile up enough sand, you get sandstone. You pile up enough mud, you get mudstone, and so on and so forth. And that's mostly what we're seeing out there when we look at the rocks of Grand Canyon. It's all those layers of sedimentary rock. And each one of those layers formed in a different depositional environment. It's a different kind of rock that formed in a different environment on Earth. And as you go up through the layers, they actually tell you about how our planet was changing over time. And I like to think of them actually as pages of a book. Like a gigantic book sitting out there. And each one of those different layers or formations of rock is a page, or a chapter actually rather, in that book. The smaller layers are the pages. And so, like these layers of rock out here, these pages of this book are almost like a gigantic story about the history of our planet. And as you start way down there at the bottom, you work your way up through younger and younger and younger rocks, moving forward in time. You're reading that story, turning the pages of that gigantic book. And it's a really incredible story. It tells us about things like rising and falling sea levels, the uplift and erosion of mountains, earthquakes, volcanoes, the continents moving across the earth and slamming into one another and then breaking apart again and opening up oceans in between them. These are really, really incredible stories that rocks at places like Grand Canyon tell us. And that's why we study them. That's why we study the science of geology. And Grand Canyon is pretty much the premier geology classroom in the world. I'll tell you, every geology student in the entire world wants to come and see this place. It's near the top of their list, I guarantee it, of places that they want to come and visit. It's featured in pretty much every geology textbook ever published, and pretty much every geology student wants to come here to see this incredible place. So that's why geology outreach and interpretation and education is so important to us here at Grand Canyon, which is why we're putting on this GeoFest over the course of this week. So one other question I wanted to address that might not be covered in such great detail over the course of this week is a fairly common question is, why is Grand Canyon here? Why is it here in northern Arizona? Why is this incredible geologic feature here and not somewhere else? Not somewhere else in the world, because this is the only place you're going to see a landscape like this, I guarantee it. Well, I like to think of Grand Canyon, or the whole Grand Canyon region, kind of like a cake. Not just any kind of cake, though, a very special kind of cake. A layer cake. A cake made of different layers of different flavors stacked up on top of one another, just like those different flavors of rock that we have out there in the canyon. And just like a cake, you need a recipe in order to form a Grand Canyon. So what are the ingredients in that recipe that we need in order to form a Grand Canyon? Well, the first one, pretty simple, we've talked a lot about it, rocks. We need lots and lots and lots of rocks in order to get a canyon this deep. They can't just be any kind of rock, though. They have to have different kinds of rock stacked on top of one another. You need really strong rocks tightly cemented together, and then you need really soft, weak, crumbly rocks that fall to little bits and pieces, just like what we have out here in the canyon. You look at that landscape out there and you see a pattern of cliffs, very steep sheer cliffs, and then soft, crumbly slopes. The cliffs are the strong rocks that are very tightly held together. The slopes are the soft, crumbly, weak rocks. And Grand Canyon would look very different if we didn't have that pattern of different kinds of rocks stacked up on top of one another. Because rocks erode at different rates. And that pattern of alternating rock types is what gives us that incredible topography that we see out there in the canyon, that pattern of cliffs and slopes, all of these really amazing kind of buttes and mesas and peaks that you see out there, these ridges sticking out there. It all has to do with the fact that some rocks are eroding much faster than others. As the soft rocks erode back from the Colorado River, they undercut the stronger rocks above, which then collapse and break as giant landslides. So the widening of Grand Canyon has to do with those different rock types. And it's a combination of very slow and gradual erosion, and then very rapid erosion as some of those strong rocks break and collapse as large landslides. So we need lots of rocks piled up on top of one another, different types alternating one on top of another. That's the first thing we need. And of course, you can only really get a stack of rocks like that in basically one environment on Earth. And that environment is in the ocean off the coast of a continent. A place where tons and tons and tons of sediments are eroding off of the continent, being dumped in the ocean and slowly piled up one by one. And the story, and we're going to hear a lot more about this over the course of the coming week, the story of these alternating rock types over time has a lot to do with changing sea levels over hundreds of millions of years. So once we have our stack of rocks, our layer cake of different types of rocks, what's the second ingredient? Well, you got to take that cake, stick it in the oven, and let it rise. Uplift. The second ingredient is uplift. I am standing currently on the south rim at 7,000 feet above sea level. One thing to remember about rivers is they're trying to get to the ocean. They're trying to get down to sea level. And they can only cut their canyons down to sea level. So if you have rocks that are only a few hundred feet above sea level, you're not going to get a very deep canyon. You need rocks that have been lifted thousands of feet above sea level in order to get a canyon like this. Problem is, most of the time when rocks get lifted thousands of feet above sea level, they're in mountains. And they're not flat anymore like these are. They've been tilted and folded and broken up. All kinds of crazy things have happened to them. These rocks up here on the Colorado Plateau are still almost perfectly flat. And again, Grand Canyon would look very different if that were not the case. So, uplift, second ingredient. You got to take those rocks, lift them to thousands of feet above sea level while keeping them relatively flat, which is pretty rare on the surface of the planet. Not many other places like that. The Tibetan Plateau in China, pretty high plateau with fairly flat layers of rock. The Andean Plateau down in South America will also, but they don't have the right conditions to form a canyon like this. Third thing, pretty simple, we need a river. We need a river to flow through that region, cut down through all those layers of that layer cake, all these layers of rock, to expose them like we see today. Fortunately for us, the Colorado River has done just that, although that's a very complex history I'm not going to get into right now. Our speakers over the course of the week will get a lot more into the cutting of the canyon by the Colorado River and, give you a hint, other rivers as well. So, that's still not enough, though. There's actually one more thing that we need in order to get a canyon that looks like this one, and that actually has to do with climate. All these things need to be happening in a very specific climate, namely a desert, a very dry, arid desert climate. And that has to do with the processes that are widening the canyon. A lot of folks look at this thing and they say, well, how can that little river down there, which is about 300 feet wide, by the way, how can that little river have cut this gigantic canyon? Well, it didn't. Not entirely. It's the downcutting force. The river is what actually slices down through the layers of rock. Other erosional processes are what widen the canyon. Things like water getting into the cracks in the walls of this canyon and freezing and thawing and expanding and pushing those cracks apart, breaking and crumbling up the rock. And then we get these big rainstorms. In the spring, all the snow we get during the winter is melting and rushing down there to the river at the bottom and carrying literally tons of rock along with it. So the canyon is slowly widening, the north and south rims slowly moving away from the Colorado River as the canyon gets wider and wider and wider, and as the river down there at the bottom cuts deeper and deeper and deeper. So those are the ingredients that we need in order to form a Grand Canyon. A big thick stack of layers of rock piled on top of one another of different types, lifted thousands of feet above sea level, with a river flowing through a desert. And only here on Earth, at least today, do we have all of those conditions necessary to form a canyon that looks like this one. There are other canyons out there that are actually bigger than Grand Canyon, deeper, wider, even a little bit longer, although not very many. But none of them look like this. None of them look like this because they don't have all of those ingredients necessary in order to give us this incredible landscape. And that's why Grand Canyon is such an amazing place, unique in the world. It's why geology students from all over the world, geologists, flock to this place to learn about it and understand it because it helps us understand the science of geology. And that's why we're putting on this GeoFest here this week, so that you can all actually connect with some of these amazing geoscientists who have learned so much about the geology of Grand Canyon. So I hope you enjoy all of these talks over the course of the coming week. I know I will very much enjoy sitting down and actually talking with these folks. Please ask as many questions as you want over the course of the week, and we'll try to answer all of them as we go. And now, the next kind of a little event here for our welcome or kickoff day, I'm actually going to sit down and have a conversation with two of the other conveners of GeoFest 2020, our partners at the University of New Mexico, Dr. Karlstrom and Dr. Crossey, about an amazing geoscience exhibit that they installed here on the south rim of Grand Canyon called the Trail of Time. It's one of my favorite things here at Grand Canyon National Park. So hopefully you stick around for that conversation about that amazing exhibit. If you've seen it, great. If you haven't, please, keep it in mind. You come to Grand Canyon National Park, go see the Trail of Time. But I hope you stick around for that talk and for all the talks to come over the course of this week. Thanks for joining us. Once again, I'm Park Ranger Joel Kane. You'll be seeing a lot more of me over the course of the week if you decide to tune in, which I hope you do. So, thanks again. All right, well, hello everybody, and welcome to another talk here on our opening day of Grand Canyon Geology Festival, GeoFest 2020. We're today on the very first day, kind of giving you a little bit of an introduction to what I'll be talking about here over the coming week. Here to give us an introduction and some background on a really amazing geoscience exhibit here at Grand Canyon National Park. Two of the organizers of this whole event, this whole week of geoscience education, Dr. Karlstrom and Dr. Laura Crossey from the University of New Mexico. Now, Dr. Karlstrom, he's a professor there at the University of New Mexico. And he's been hiking, boating, and doing geology at Grand Canyon for 4.5 decades, since he first hiked the Grand Canyon in 1965. And as a professor at Northern Arizona University down in Flagstaff, and now the University of New Mexico, he's been interested in both the research and imparting new knowledge gained from the research to students and park visitors to enhance geoscience education and science literacy. Dr. Crossey, also a professor in the Department of Earth and Planetary Sciences at the University of New Mexico. Her research emphasizes geochemistry and hydrology, especially springs in Grand Canyon, and she has worked on research projects in Tibet, Egypt, Australia, the Rocky Mountains, and of course Grand Canyon. Laurie and Karl are married and joining us jointly today from Albuquerque, New Mexico. Dr. Karlstrom, Dr. Crossey, thank you very much for being with us here today. And thanks for all of your hard work in organizing this amazing event. And of course for putting together this amazing Trail of Time exhibition here at the Canyon that is one of my favorite things here on the south at Grand Canyon. So
great. Well, thanks for the introduction, Joel. These are all good team efforts. I was doing the math while you read the introduction, 1965 to, it's actually 5.5 decades, but I screwed it up when I sent you that information. But
oh, wow.
Not a good sign when you're dealing with the Precambrian to be off by that big of a fraction.
Let's just call it 5 decades. We'll just round it off. Anyway, I have a great attachment to Grand Canyon and a great attachment to both teaching and research. And this Trail of Time exhibit was an outgrowth of both. With Mike Williams, we concocted the idea in 1995 that our research advances needed to be promoted. And we'll talk a little bit about how we put it together. But I want to mention a concept which came out of the evaluation for the Trail of Time, this idea of multiple learning levels, multiple learning hierarchies. So just like this whole week, this GeoFest, we're aiming high and we're aiming low and we're aiming in the middle. There's something for everyone. We want to impart new knowledge at the same time that we're bringing everyone along with the basics of the geology in one of the world's premier geologic laboratories. So Trail of Time exhibit there and back again. Just to start, people need to know where it is, and it's a wonderful hike along the rim trail from Geology, Yavapai Geology Museum. So you start there, spend a few hours, and you walk that first segment, which is the Million Year Trail. I'll tell you a little bit about that in a minute. And then you walk the next segment, and you just take one step on the timeline. 1 meter is 1,000,000 years, and you get to the village after about 2 kilometers of walking, 2,000 steps. Now, you know, you can go into any of the places in the village, but we marked right through the village. We weren't able to put markers in the historic village, but we marked through there. So then we pick up again near the Hermit's Rest bus stop for the early Earth Trail. So that last segment, that's my favorite in terms of views, to be honest with you, all the way to Maricopa Point. But if you walk the whole thing, you've walked 4.5 kilometers. It takes half a day or maybe a full day if you take your time and get ice cream at the village and all that. But it's a great family endeavor because it's fully accessible for strollers and wheelchairs, etc. And it's just spectacular geology. The idea in 1995, this was an early drawing, and you can see I was envisioning Volkswagen-sized blocks beside the trail. The rocks that we got on the trail are beautiful. They're not quite this giant. But the idea was to connect the views, the rocks in the canyon, with where they would sit on a geology timeline. And so here's one of the portals. I just want to mention this Trail of Time companion. Lori and I put this walking guide together since the trail opened in 2010, and then we put this book out in 2019. It's a really handy reference for the trail walk and also for geology essentials for anyone's visit. So grab one of those from GCC if you get a chance. Why don't you tell about the 1,000,000 Year Trail?
Sure. I'll start with the young end, Karl, since I like to work on young things in Grand Canyon. The representation here is how we approach getting a feel for the deep time of geology. We call it the problem of the illions. There's millions, there's billions, and people simply don't comprehend that length of time. So we have an on-ramp to the trail called the 1,000,000 Year Trail. This is the first segment that starts out of the Yavapai Geology Museum. You trot down past the restrooms, get your last stop in, and then you start on the 1,000,000 Year Trail. It starts with a marker that says today, and then it goes through time, and you're going to be walking back through time, but it starts with years, something that people are familiar with. Family groups can spread themselves on and find their birthday on the trail of time. And then we go to decades, and then to centuries, and then to millennia. And so we look at all the different time scales of things that happen within 1,000,000 years.
And all the time you can watch the age of the Earth over there at the Maricopa Point portal. That's 4,600 steps away. So that you keep an eye on where you are in time.
So essentially the 1,000,000 Year Trail is from here, and then you walk the main trail to the village, and then around the corner and out to the age of the Earth. And so right from the very beginning of the trail, you get a glimpse of the entire span of geologic time using a timeline to substitute for the age of the Earth. Other aspects of the trail, we'll go through the different components of the trail, but of course the first thing that anyone would notice are these large portals which are constructed from actual rocks collected within Grand Canyon from the appropriate layers. So there's a welcome to the 1,000,000 Year Trail, and at each portal there's a series of seating rocks where people can gather and get together and think about what they're going to be seeing. And the stone that is used in the landscaping of the portal areas is different depending on what time is represented by the portals. So at the 1,000,000 Year Time portal, we used the most young rocks that we have in Grand Canyon's history, which you'll hear about in the coming week in more detail. But there's the basalts of Western Grand Canyon shown there as a columnar basalt, and also the paving stones of beautiful travertine, which are spring deposits. Even the rock that's even forming today in Havasus Creek and the Little Colorado River.
The youngest rocks in Grand Canyon.
Well, when you come to the end of the 1,000,000 Year Trail, you have ramped up, you've got your 7-league boots on, and each step is getting longer and longer as you're striding back through time. And so you've seen everything that happened in the last 1,000,000 years at Grand Canyon, and now you're ready to walk the main trail. So the trail itself switches over from the left side of the asphalt, or the side away from the rim, over to the side closest to the rim to make it very clear. And there's a magic meter pictured in the lower right there that's literally a bronze meter inscribed with all of the 100,000 year markers And then as you come to the present, this recent part is inscribed and illustrated on the wayside exhibit right there, which shows you all the most recent things like human occupation of Grand Canyon, which occupies such a small portion on the scale of geologic time.
And there's little secret squirrel stuff. See the red stars that you can see, nice reptile tracks in the Coconino sandstone if you know where to look. So that's
so the seating area here is paved with rocks from the Paleozoic.
Yeah, there's fun stuff encoded that you have to figure out, or you can figure out. And then the amazing thing is you got 4,600 steps ahead of you, but the first 6 meters is the time it took for the Grand Canyon as we know it today to be carved by the Colorado River. And you can see this beautiful, that's my favorite rock wayside, that river polish rock. The river polishes the banks with its tools of sand and gravel, and you get these beautiful, beautiful rocks. So 6 steps, that's all. It's a young canyon carved into very, very old rocks. And you know, the rivers, there's this river sawing down, the river polishing, and these signs, how many did we make?
Well, we were limited to about 15 waysides in the entire 2-kilometer main trail of time. And so the idea is that many people revisit the Grand Canyon, many people use the rim trail for purposes other than, say, geoscience interpretation. So the exhibit is as unobtrusive as we could get away with while still illustrating the main points. So the waysides are few and far between, but if you think of each wayside as the real estate where you are going to help an interpreter understand what they're seeing geologically, here are the different elements that are on each wayside. A very short topical sentence at the beginning that's written in a conversational tone. This helps visitors of the entire age spectrum be comfortable with what's being said on the sign.
And then there's action verbs, touch, imagine, walk. And then the lower part tells you where you are, so you can find the nearest bathroom and the nearest exit or entrance to the trail. Those are important things. So, you know, we would listen to people, and in the evaluation, we did this rapid prototyping, trying improving the words. And we came up with this idea of conversational tone. And you'd see a family group coming along, and you'd be hiding in the trees or something to observe. And they'd walk by and they didn't even stop at this sign, let's say. And I would be really, really discouraged. But then a little farther down the road,
you would hear somebody in the group say to the next, did you know the top layer is 270 million years old? So somebody was looking, and
so the conversational thing really works. And so let's see. Yeah.
The other aspect of the complexity of the task that's taken on by the Trail of Time exhibit is to connect a horizontal timeline to the vertical stratigraphy depicted in the familiar form that you see of the 3 major rock groups of Grand Canyon. And we would point to where people are in the stratigraphy to try and reinforce the connection that as you go deeper in the canyon, you're going back in time. This is one of our big cognitive challenges of this science exhibit.
And you can see the formation names are phonetically spelled out, Coconino, to help people be comfortable with names that are initially not familiar. But you get to know them. And there's long stretches of the trail where there's no rocks. What does that mean? Well, it's a visceral. These are rock waysides. They're so gorgeous. But go back one. Just there, 470. There's no rocks there. That means time passed, of course. Time went on, but there's no rock record of this particular period of time in Grand Canyon. They're called unconformities. So it's a visceral way to understand that even though Grand Canyon is one of the best records in the world, there are sections of that geologic history that are not recorded. Look at those things, nice stromatolites, nice igneous rocks. So you get, people love to touch them and polish them, and they're getting shinier and brighter as people polish the rocks. You get to the end by the village and you see a bunch of rocks bunched together, all those little squares. Those are the basement rocks, the Vishnu basement rocks. And you know that something big happened in that period of time, happened to be the formation of our continent by the Yavapai orogeny. But, and then you exit by the portal there, and there you are in the village.
So the rocks are truly the rock stars of this exhibit. They're so beautiful. So One of the things that came up during the evaluation was a series of comments. People are encouraged to supply comments with what their experiences are in the park. And someone said, you can read it in a book, but your eyes glaze over. It's better in little bits along the trail. And that's a quote from a visitor during the prototype testing. So here you see looking deep into the canyon at that spot, pointing to the basement rocks. And there we see a gorgeous piece of Vishnu basement rock. So gosh, how did that rock get there? How did we actually do this exhibit? Well, we're going to segue now into a little bit of the how. This is where we say there and back again. We went down the river on rafts. We collected the rock strata as the Colorado River carves down through each rock layer. And what a treat and what a difficult task to select from the abundant, beautiful stones in Grand Canyon, the one representative for each of the rock units that we depicted, which was on the order of 60 rock units that we collected. So here's Karl sampling where possible. We took tailless bits of material that had already been released from the outcrop. We were going to take these back and then cut them in half to expose what a geologist really likes to see, which is the inner structure of each particular rock. So we had to measure them because we had to be able to carry them in the inner canyon environment on a stretcher. And so each rock had to be of a size that could be carried by about 6 people on a rock stretcher.
And you can see the footwear's OSHA approved rock carrying footwear.
Yes, sandals on slippery rocks near the river. So we carried each one to the raft. What does a raft look like with 6 tons of rock loaded on it? So here's Joe Pollock from Arizona River Runners, who along with the National Park Service lent us what are called S-rigs, the large boats that would be capable of carrying these rocks. And here it is, as we went downriver, heavier and heavier with the loads of stone on there.
Keep in mind the rocks are the rock waysides, but they're also the rocks for the portal. So these particular ones on the side of the boat would have been cut to make the layers in those rock portals.
And you think it's challenging going through the Class 5 rapids on the Colorado River with a normal load. We had very little freeboard, and so here we are smashing through a rapid with that load of stone on there. When we got to the other end, we had to unload all the stones, and then they were put into a big truck here, pictured on the right-hand side, where they were actually driven back to Belen, New Mexico, right near our home here in Albuquerque, where there's a stone cutting facility which cut all of these large slabs beautifully and polished them for the presentation on the trail.
And the portals were made in Colorado by Rock and Company. So some of the rocks went to New Mexico, some to Colorado. They all found their way home.
They all ended up there at Grand Canyon National Park. Now, for the large seeding stones, those were not capable to be carried in the methods that we were using on the river. So we had a day where we had access to the heavy lift helicopter that was rented by Grand Canyon National Park. So we had the fun of going in a helicopter. We would be let out with Karl Bowman, who you'll hear from later in the week, on the ground. We wrapped these things in mesh. And then below this helicopter, maybe you can make it out here, we slung 1, 2, 3, 4 stones, each of which weighed hundreds and hundreds of pounds, that was lifted and strung in what's called a daisy chain fashion to be carried out of Grand Canyon. So a little bit of helicopter time was involved in fabricating this exhibit. But endless drilling.
You know, we got $2.5 million from the National Science Foundation to design and install the exhibit, and the park contributed a great deal in terms of in-kind support, the helicopter, the time of various interpreters. We thought that the trail crew was going to be able to drill all the holes, the inset for the inset bronze markings, but that happened to be a year of major landslides and trail difficulties in the canyon. So the UNM team, here we are, they loaned us a Polaris and a hammer drill. And here we are, drilling all the holes ourselves and installing 2,500 holes. And if you walk the trail now, you'll see some of them are still beautiful 10 years later. But when we first started doing it, we didn't quite have the technique. So there's a few missing right now, which we hope to be reinstalling over the Christmas break. So it's constant maintenance, but it really was a great partnership between the park and academics.
Yeah. And we did have a team that extended beyond the University of New Mexico, and that included Steve Semken and his students from ASU who came up. They did a lot of work on the Million Year Trail especially. And then we also had Mike Williams, as Karl mentioned earlier, who's from the University of Massachusetts at Amherst. And he came out and helped install some of the markers as well. So it was a real group effort, but mostly University of New Mexico students, grad students, undergrads, weekends, holidays. For about 6 months, we came out, and it was a good day if we could get through, 200 million years. That was a long day of work and drilling on that trail.
And here you can see some of the main players. Mike Williams on the right. We haven't mentioned Ryan Crow, but he was doing his PhD, in part funded by the Trail of Time. He's a mainstay throughout the project. Steve Semken, with a role in geoscience education and indigenous science education. There's Judy Helmick Bryant, who was chief of interpretation at the time, myself, Laurie, and Steve Martin, who was the superintendent at the time. And his opening ceremony, 2010, it really was an excellent team effort, and a lot of people are not listed or shown who contributed greatly, and they, it was that team effort that made it happen. So we hope you'll go and see it, and think about all the things that happen in the history of our nice planet, Mother Earth.
Okay. So back to you, Joel.
All right. Well, thanks. Yeah. The Trail of Time, like I said, is one of my favorite things here at the park. I love it as an interpretive tool, as an educational tool. Never get tired of walking on it and pointing out to folks some of those hidden things you mentioned. Yeah. I kind of love that idea that there's all these kind of cool little hidden things in there, sort of like the canyon itself in a way. It's full of kind of like little secrets that you need to figure out. So.
Joel, we had workshop meetings with, of course, many interpreters, and not just from Grand Canyon, but we drew from the Park Service in general, people from different parts of the region. And this idea of having elements in the exhibit that were discoverable by the visitor, but not like technically interpreted, like using meters instead of yards, those were things about the Trail of Time that were a little bit non-standard for some of the conventional park interpretive style. So, we did do mostly, we were going to have more of the exhibit be discoverable, like not mention any of the formation names, let people, use their other park materials to find it. But, that didn't make sense. And so it gravitated to where it is.
The other thing that was non-standard was the interpretation. We failed to mention Deborah Perry from Celinda Research Associates and her team. It came out again and again and again on prototype trails we'd mark it with, plastic tape and chalk and signs on plywood and what their museum exhibit experts and the concept of multiple learning levels rather than aiming for the 8th grade level or whatever. Really, the interpretation that went into this made it much better than our original ideas, which had signs packed with words like professors would give, but it was.
So the idea that there would be something for everybody on that sign, a little tidbit, and then the hidden stuff, there's so much more there that can be done with college groups or people like yourself that give you that feeling like, hey, here's the inside story. So we just love it.
I liked going out. I go out on the trail that's my favorite section of the rim to walk on, because there's so many opportunities there to engage with people and talk with people about geology, which is kind of the thing I like to talk about most here at Grand Canyon. And what you were saying, like hiding in the bushes and kind of listening to conversations along the way, I do that sometimes, and I'll, you know, I don't exactly like crouch down and hide, you know, and peer through the bushes, but I do just kind of hang out sometimes in areas of the trail and listen to people's reactions and what they're talking about, and sometimes I'll overhear them asking about, like, well, that doesn't make sense. So what's this? And then I'll just kind of appear out of nowhere and be like, oh, well, let me tell you about that.
Yeah. I'm glad you asked.
You know, I love hearing geology spoken in so many languages. Visitors come from all over the world to Grand Canyon, and so you'll see a group huddled around talking about geology in French or Spanish or Chinese or whatever, you know, and it's quite fun. I wish I could listen more to those.
And Joel, you yourself know, because of being there all the time and as an interpreter, I hadn't really given thought to the vast numbers of people that have disabilities or have challenges of one form or another. And the fact that we kind of, you know, because we were designing this exhibit, we incorporated best practices about legibility sizes and accessibilities and having a high and a low view tube and the whole thing. And I can say that there's probably not one day when I'm out on that stretch of trail that I don't see a wheelchair or some other way that people are so happy to be able to access this beautiful resource of geology, to touch those layers when they themselves may not have an opportunity, like only maybe 10,000 people a year do, to actually go in the canyon, which is the preferred way to appreciate the geology of it.
Exactly. Yeah. And I know I'll often tell people about, you know, when I'm talking about the Trail of Time, you know, like, it's awesome because you can walk along the rim. And it's pretty flat, pretty gentle, easy walk, you know, and you can see all the rocks of the canyon from the top to the bottom, without actually having to hike all the way down to the bottom of the canyon, which, of course, it's a long, difficult hike to get down there. So,
you know, and you yourself know also that as you're hiking into the canyon, it's not all that obvious, you know, many of the different layers. So, you know, we encourage, we bring groups of students over there, college students. We're planning to, say, hike out to Plateau Point, but we go along the trail first, kind of give them an introduction, let them see the canyon in all its glory. And then when you're hiking down in the canyon, you can start to focus on one bit at a time, but it gives you a little preview. Just as given our visitors today a preview of the whole week of the geology of this amazing place.
So Joel, you know, we still have a challenge ahead of us, and that is there's a lot of neat elements of interpretation of the sciences at Grand Canyon. There's the Yavapai Museum, there's the Trail of Time, there's the website, there's many things. And I think this idea that you can continue to improve and integrate different elements into a cohesive science education program, I think is so important for the parks and especially for Grand Canyon. And I look forward to working with you for the next decades to...
the next 5.5.
Yeah, next 5.5 decades to make it as seamless as possible, to just do as good a job as we can.
Absolutely, yeah. Yeah, I mean, the Trail of Time is just, it's an amazing exhibit, and it's one of the coolest exhibits I've seen, like, in any national park, any museum, anywhere in the world. And it's a tool that we can use, that I make use of, like, as an interpreter. You know, I lead part of a walk that I do, where I'll stop at 2 of these portals and I'll wave my hands around and talk about all kinds of different things, like about time, because it's such an important concept to try and wrap our heads around when we're talking about geology. But it's also designed to be self-guided, and people can go out there and walk it at their own pace and you know, discover some of those little hidden things that you were talking about. And now you put that book out there, the companion guide to it, which makes it, I think, it allows people to go even a little deeper. So yeah.
Good. Well, it's going to be a great week. We're going to hear more about geology than you would hear in most weeks. that way.
Absolutely, yeah. We have a lot of really amazing talks lined up, and including a few with the two of you as well, along with a lot of other folks. Looking forward to seeing how the week goes.
Great.
Me
Thank
too.
you, Joe.
Yep.
Of course, thank you. All right, hello everybody, and we're here the final event for today, the first day, the welcome day for Grand Canyon Geology Festival, or GeoFest 2020, and we thought we'd wrap things up today with a little bit of a roundtable discussion with some of the conveners of this event, because it's not just being put on by the National Park Service. We're also doing this in collaboration with some other folks. So we all got together, and we're here to hopefully answer any questions you might have. We're encouraging everybody to ask those questions throughout the entire week. If you ask a question earlier in the week, we might just get to it, at some point later on in the week. So please don't hesitate at all to start asking those questions as they come. So, I would like to introduce the conveners of the event here. Of course, you've already heard a little bit from me, and you've heard a bit just a little while ago from two of the other conveners here. So, once again, I am Park Ranger Joel Kane here at Grand Canyon National Park, and I'll be your kind of your recurring host and guide, throughout this week of GeoFest. And our other conveners. Sorry.
Karl.
I'm Karl Karlstrom, University of New Mexico.
Laura Crossey, also at the University of New Mexico.
Hi, I'm Ranger Ronnie Colvin, also with Grand Canyon National Park. I'm an interpretive ranger here and also a paleontologist.
That's great. As Joel mentioned, we have a number of partners. So in addition to Grand Canyon National Park and, of course, the NPS, we also have the University of New Mexico, where Karl and I are. And we couldn't accomplish the research that you're going to be hearing about in the coming week without also the support of the National Science Foundation. So we want to acknowledge those three partners that have come together. And then all four of the conveners want to thank our speakers who so generously gave it their time so that you could hear from them in the coming weeks. Just to reiterate what Joel asked, we won't necessarily answer the questions immediately, so keep your eye peeled. We may come back to your question, or one of our speakers will come back to those questions throughout the entire week. So we're so glad you're joining us, and be sure to tell your friends and family to watch throughout our Science Week.
We're going to compile all those questions. Should be a great set. But so Monday, tomorrow, we'll have 4 talks. I'm going to talk about the Vishnu basement rocks, and then Mike Timmons is going to talk about the Unkar group, Carol Daler, the Chuar group, and then Ron Blakey's going to talk about the Paleozoic rocks. So we'll have a discussion of the 3 sets of rocks that make up the walls of Grand Canyon.
So that's Monday. And then on Tuesday, we're going to have the main topic be unconformities and missing time. And that's going to be starting with Making Sense of the Supergroup by Wayne Ranney. Then Grand Canyon's Great Unconformities by Karlstrom. And then The Mother of All Floods, the Tonto Group. That will be by James Hagedorn. And then Detrital Zircons from Grand Canyon Strata, an incredible journey, brought to you by George Garrels.
Then on Wednesday, we're going to be celebrating National Fossil Day on Wednesday. It's going to be the 11th time that we've gotten to do this. And we're going to have some speakers throughout the day. We've been busy with some of the park paleontologists going behind the scenes in museum collections and out in the field to take the visitors along with them to see this. So that's going to be kind of fun. Those premieres will run at 10 a.m. and noon Arizona time, or I guess that would be Mountain Standard Time. And then in the evening, for our speakers at GeoFest, we're going to be having a nice lineup. I will read those to you. We have The Oldest Fossils in Grand Canyon, and that's by Susanna Porter. And then that's going to be followed by Clues to Change. And that is, let's see, that is also by James Hagedorn. and the oldest vertebrate footprints in Grand Canyon. Those are the new tracks that we've been talking a lot about here from Steve Rowland. And last but not least, the Paleozoic fossils of Grand Canyon by our own park paleontologist, Ann Miller.
All right, yeah, and then on Thursday, we're going to be talking all about time on Thursday, trying to wrap our heads around geologic time, which is kind of one of my favorite concepts in geology. So kicking things off, we've got As Time Goes By, The Numeric Ages of Grand Canyon Rocks by Karl Bowman, and then Deep Time and Uranium-Lead Dating of Zircons, How Do We Do It by Mark Schmitz. After that, It's About Time, Contributions of Geochronology and Understanding Grand Canyon by Matt Heisler. And then finishing things off that day with Uranium, Thorium, Helium, Thermochronology and Applications in Tectonics by Willie Gunthner.
And then Friday, we make an important transition. You know, one of the hard concepts for many visitors is that the canyon itself and the landscape, the erosional landscape, are young features carved into really, really old rocks. So we're going to switch on Friday to looking at the landscapes. And Wayne Raney's going to start with a history of ideas of scientists who talked about the landscapes. Dick Young is going to talk about the Western Grand Canyon landscape evolution, reversing rivers. I'm going to talk about the lava dams, hot stuff, volcanism and lava dams. And then I'm also going to talk about the age and carving of the Grand Canyon.
Well, it sounds like nothing but rock, 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 but there's water too. So on Saturday, we're going to also think about how we do outreach and reach across many different cultures on geoscience topics. So our Saturday finale is going to start off with Steve Semken with place-based education and interpretation of Grand Canyon. And then we're going to have a talk on Grand Canyon springs and travertines by Laura Crossey herself. And then protecting Grand Canyon's water supply and backcountry water sources by Abe Springer. And then we'll finish off with probably some greatest hits questions, puzzles that you have provided us with through the chat during the Facebook premieres throughout the week. So some of that's in your hands. Be sure to pose your questions. We hope to stump the experts, and everyone will be charging in and answering throughout the week. Even if it's Thursday, we may be answering a question from Monday or Tuesday. So keep peeled and watch your notifications.
Yeah, definitely. So, yeah, we definitely want to encourage everyone to participate over the course of the week in these talks. Part of the reason we're doing this is so that folks can actually kind of connect with some of these geoscientists, these researchers and educators as people, and actually ask them questions, interact with them, whether it's in real time, during the talks, or maybe later on. So
I heard a rumor that some of the researchers may be posting photos of some of their colleagues in the field in the chat as we go. So keep your eyes peeled for some behind the scenes information that way. Secondly, we also know that a lot of people are either doing, home education, supporting your public education during this time of COVID. There's college professors and all sorts of folks out there. I want to encourage you to look at that schedule, and if you want to, encourage your students to submit questions, maybe that's even part of an assignment. We are happy to follow up with your classes and so forth. So we hope this serves everybody, and we're really looking forward to spending the evenings with you in this coming Earth Science Week.